Chapter 2, Part 2. So there is the second method they call the stem and left method. This is another method how to get some data and organize it. So one advantage of this method is you could start from number 1. So you have all these numbers here, and you could start from the first one, go all the way through the end. The way it works is here, since there are 2-digit number, each number is 2 digits. It's 76, 72, they all are 2-digit. So we start, the lowest number is 60, and the highest is 124. So the very first digit is 6. We don't have any number that start with 5. So the lowest first digit number is 6. So we draw the vertical line, and we call this column stem. The very first number is 6, 7, 8, 9, 10, 11, 12. It doesn't matter whether we have the list of these numbers or not, but we still have to have all in order. Like, we don't have really any numbers start with 11, but still we should have it here. Why? Because horizontal axis is divided into equal section, and it must have all the number listed. So when the first number is 6 and the last one is like 12 or 124 or 12, then you should put 6 and 12 and list the rest of the numbers that are between these two. All right, so then we start counting from the beginning. 76. So 7, 6. They don't have to be in any order. All right. So if I want to start and prepare my list, let's say here I start with 6. Like here is my 6, 7, 8, 9, 10, 11. The first one is 7, 6, right? So I'll put here 6. The second one is 7, 2, so I put 2. Then it's 88, then I'll put 8 here. Then it's 60 or 60, I'll put 0 here. Then 72, you put another 2 here. 68, you put 8 here. 80, you put 0 here, see, 80. And 64, 64. So you understand? So you list all the numbers here. Whoever did this problem, they put in order, but they don't have to. So as you go from left to right, you could list all these numbers in all these horizontal axes, okay? So when, like for instance, do we have a number that starts with 10? 104? 104. So 104. I don't have any number with 11. Still is okay. So you don't have this part. See, I crossed it out here, so it's not very clear. So I showed you here. 11 is blank. It doesn't have any number. Okay. So when you list all the numbers this way, and see, you could also look at this one. Then, right after you finish, all you need to do is turn it. By turning it, you see your histogram or the bar graph. Okay? That's another way of graphing your histogram by method of stem and left. If I actually take the highest point of each rectangle, if I connect this, you have some kind of bell shape, but it's skewed to the right. See, if you take the top one of each and connect it, then you see that curve that's go to the right. So this is a method of stem and left. I'll show you more example of this method. Now look at all these numbers. The very first, so these are height of, use the height to construct the stem plot height of eruption signal. So these numbers are all collected, and the very first number is 9, the lowest one. We can't use the first digit because most of them has 1, okay? So we start with this one, 9, 10, 11, 12, 13, 14, 15. And then you start from here, 129, 129. 110, 110. 150, 150, and so on. And then, we explain here that the distribution is not dramatically far from being a normal distribution with a bell shape. So if you turn it and you see a kind of bell shape, it's not really skewed to the right or to the left. So it kind of give you a bell shape graph. Sometimes in the problems, we give you the stem plot already, and we ask you to list the numbers. Like, what if I give you these problems and I say, you know what, why don't you list all the numbers? How would you do that? Like, if I give you this and ask you to list all the numbers, you just say, okay, one number is 90, and then is 100, and then another number with 105, 105, and then 110, I have 110, I have another 110, I have another 110, and I have 113, and I have 114. So if we give you this part and ask you to list the number, that's how it works. Okay? Like, how many numbers start with 12? Is 120, another 120, 125, 125, and 129, and so on. Okay, that's why you see all these numbers here. So here I give you a blank problems so you could work on it, and then the solution is on the next page. Because I didn't put the page here. Okay. Now, there is another method they call it dot plots. A dot plots consists of the graph in which each data value is plotted as a point or dot, like these examples. Okay. Now, I'll start with a small example here. I have collected some data for volume of the soda. These are the numbers. Now, what you do is the lowest number is like 50 and then goes all the way to 85. So you could start here and you could just say, okay, we start at 50 and maybe 90 and divide it into equal pieces. Like from 50 to 90, you could divide it into equal sections. So it's 50, 60, 70, 89. Then you have I have 65. How many 65 do I have? 1, 2, 3. I have just 365, right? So you get a better picture here, look. So above 65, you put 3 small circles. That means you have 3 of the 65. How many numbers, how many 70 do I have? I have 1, 2, 3, 4. So here, 70, 1, 2, 3, 4 dot for a small circle. How many 75? 75, you have 3. How many 80? 2. How many 85? Just 1. And you have 150. This is it. So there are altogether, there are 14 dots. This is another method to graph a histogram. The dot, they call it dot plot. Dot plot resembles a bell shape in a normal distribution. The frequency is to maximum and then decrease. So it shows that the curve goes all the way to the maximum and then drop. So it gives you a kind of bell shape. So this graph is symmetric with the left half of the graph being roughly a mirror image of the right half. If these two are kind of image of each other in respect to this line. So these examples, I put the answers at the bottom so you could practice. I want you to go through this example, and if you don't understand, then you could ask me while we're in the session of the question and answers. So they want to know which one of this is actually the dot plot for that, you know? All right. So if you go to the last section, which is correlation and regressions. So we want to discuss this. So let's work a little bit of algebra. Remember in algebra, we give you equations like y equals x plus 2. And then we ask you to graph. In order to graph that, you come up with some arbitrary numbers for x. Let's say x equals 1. How do I find the y value? You take this one and substitute here. So x is 2, y is 4, x is 3, y is 5, and so on, right? And based on that, you plot all the points. Let's say 1, x is 1, y is 3, x is 2, y is 4, x is 3, y is 5. See, 3 points, and when you connect the points, they all lie on a straight line. Okay? So in that case, let's say I take the equation out. I'll just give you this graph, okay? And I'll just give you this graph and I say, you know what, x is 6. Find the y value. How do you do that? Since you already have the graph, you just go and find the 6 wherever it is. Let's say 6 is here, okay? How do you find the y value? You just draw the vertical line and go to the left. That gives you the y value, which is about 8, correct? So if I give you a graph, x and y axis, and give you some points like this. And then say x equal to 5, find the y value. You don't have any equation. All you have is a bunch of points plotted here on the x and y axis. So what you do is you say, okay, well, all these points are clustered around a straight line. You could actually put a straight line here, and these points, they all are clustered around this straight line. So in this case, we say we have a very strong correlations between x and y. There is a strong correlations because all the points are kind of lying on a straight line. So in that case, if you ask you to find the y value for x equal 5, on the x-axis you find 5, then you draw the straight line, and you read your y value, correct? So this is in case you have a strong correlations. And based on that, you could actually find the equation. If you have some points plotted, you could find the equations. The equation that you find, we call it regression equations. Regression equations is equation of a straight line that going through all these points. Okay, so this is in case you have a strong correlation. Now let's look at another example here. You have your x and y axis. And you have these points. Can you draw a straight line and all the points are clustered? No. See, this is not a good correlations. So in this case, if I say, you know what, x equal 5, find the y value, you can't really do it because you cannot draw a straight line that has all these points close to it. In this case, we say we have a very weak correlations. So this is what we're discussing in these sections. And what is it that we use to measure? R. R is the value that we use to tell whether you have a good correlation or not. So we either have a weak correlations because all the numbers are just scattered here. They are not clustered around one line like the other pictures. So this is a weak correlation, and this one is strong correlations. So look at these pictures here. R value, okay, let's look at this first. You see that here, it said, these are all for R value. R is between 1 and -1. If R is 1 or 100% means you have a very strong correlation, or if R is -1, it also means you have a very strong correlations. If R is 0 means you have absolutely no correlations. If as you go to the right, correlation becomes stronger. If your value is between 0.5 and 0.8 or -0.5 and -0.8, then you say you have a moderate correlations. Why is it positive or negative? Because the slope is either positive or negative. When you're climbing, the slope is always positive. When it's declining or decreasing, the slope is negative. That's why you have a positive or negative. So R value can be 1 in this case, and -1 in this case. So if R value is getting close to 1 and -1 means you get a very strong correlations. All right, so let's look at these pictures now here. They show you 4 pictures and they're telling you which one is a good correlations or not. Look, this is -0.9. It's very close to -1. See, very strong correlation. All the numbers are clustered around one straight line. You could actually draw a straight line here. This is also a good correlation. It's not 100% strong, but it's very good correlation. You could draw the line through all this, and all the points are clustered around this line. So R is 0.85, still is close to 1. It's close to 1, it's close to -1. These are a strong one. Correlation is 0.0. That means very weak correlation. Look at all the numbers. They scatter all over. So you cannot really draw a straight line. And this one, we are talking about linear correlation. This is a curve. So this is non-linear relationship. So what we're discussing here is a straight line. A straight line is the linear equation. So anything beyond that, like y equal x2, y equal x3, is not the linear equation. So we are talking about the straight line, not the curve. So if there is a curve, then it's non-linear relations. So again, you need to understand that good correlation is when you're getting close to 1 or -1. Now, I show you an example here that two sets of numbers are given. They give you x and y. It's like here, they give you a table of x, y. And they ask you to graph all this. They ask you to graph all this to see if you have a good correlations or not. First, we want you to find the R value. So you could actually tell whether it's a good correlation or not without graphing. You don't have to graph. First, we want to do the calculation and find the R to see if R is strong or not. This is a formula to use. This is a very long formula. In this one, we have n. How many numbers do we have? 1, 2, 3, 4, 5. That's what the n value is. 1, 2, 3, 4. There are 5 x's and 5 y value. Sum of x, sum of y. So that means you have to add all these numbers. This is sum of x. Add all this is sum of y. Then they want us to find sum of x2. Means you can take each of these numbers, excuse me, raise it to power of 2 and put it here. Take all the y value one by one, raise it to power of, what is 6 to power of 2 is 36, 9 to power of 2 is 81, 3 to power of 2 is 9, and then you add all this. This is sum of y2. What is xy? Take x and y, like 5 times 6 is 30, 6 times 9 is 54. You add all, this is sum of xy. You take all these numbers and plug in the formula. So R value is 0.795 or 0.8. It's getting close to 1. That's how to calculate R value. That's one method. That when we give you x and y, you have to do all these calculations and put it into this formula. Second method. Second method is to use this formula. In this formula, this is a symbol for sum of zx and zy. And how do I find zx and zy? I'll show you the example here. Zx is x minus, what is x bar? X bar is mean. In a statistic, when you have an x and the line by it, this means sample mean. If we give you two numbers on 4 and 2 and say take a average or find a mean, you say 4 plus 2 is 6 divided by 2 is 3. That's the sample mean. S is a standard deviation of the sample. So there are a couple of terms that you need to understand. One is, this is sample mean. This symbol is mean of populations. So you always have sample or population, right? So we call this sample mean or mean of samples. We also have the little s is a standard deviation of samples. We have this, which is a standard deviation of populations. So we are using these symbols a lot in the stat. So when you work on the problem, you either have samples or population. So you either use these two or those two. All the formulas are identical, really. They both have the same formula. So even if you mix it up and you think X bar, is mean, or little s is a standard deviation of population, you still come with the right answer because they have the same formula. All right. So this is what you need to remember as far as sample mean of population, standard deviation of sample, and standard deviation of population. All right. So here, on the second one, again, we have these two columns, right? So first, we have to create a new column, which is Zx and Zy. And how do I calculate that? So we show it here. Like for 5, here we calculate for 5, so you could see it. So for this 5, you put that here, and you put the sample mean. Sample mean is 4.8. We calculate that. And the standard deviation of the samples. So you put that one here, that gives you Z of X. We do it for all to find Zx and Zy. This sample mean and the standard deviations, how would I do it? You have these numbers, 5, 6, 4, 4, 5. How do I find sample mean of this? Or how do I find mean of these numbers? Add all together and divide by 1, 2, 3, 4, divide by 5. That's the average or sample mean. That's what this X bar means. How do I find the standard deviation of the samples? I'll show you that on the formula later. But after all this, I want to show you how to use the calculator and find all this. So it's very important for you to understand the calculator because it really makes the life easy for all this type of calculation. So these are two formulas that we use, method 1 and method 2, to calculate R value. And since everything is online, we don't specify. We don't force you to use this formula or that formula. So when we ask you to find R, if you really understand the concept, you could use the calculator and find all these numbers. Like if you want to find sum of X and sum of XY, you don't have to do all this. You could just find all these numbers through the calculator. I'll show you how it works. Okay? All right. So these are two methods. See? Here is the examples. 5, 6, 4, and I have it here because it wasn't very clear here. 5, 6, 4, 4, 5, 6, 9, 3, 2, 1. X and Y are given. So what you do is on your calculator, you have to input all these numbers into L1 and all these numbers into L2. Okay? So let me show you how to use it. So you could either use TI-33 or TI-84 calculator for this. All right. So I want to calculate. First, I need to put all these numbers into the calculator, okay? So you go to stat. See this function is stat? That's what it said, stat. So we press that. It said edit. You see that? Enter. I already have some numbers, so I want to clear L1, L2, L3. I want to clear all those numbers. This is from the previous problem that I did. How do I do that? Go to Stat again. Scroll down to number 4, clear list. Clear list. Enter. Okay, I want to clear everything on L1, L2, L3. Okay, L1 is right here. You see it's blue, so you gotta press second and then 1. Second, that's L1. You gotta put a comma if you want to ask calculator to clear a bunch of lists. So comma, this is comma. Then you want L2. L2 is here, number 2. Second, L2, comma. I don't need really to clear L3, but I'll do it anyway. Second, L3. So I want the calculator to clear all the numbers listed on L1, L2, and L3, and then enter. Okay, okay. Now, go to Stat again. Edit, enter. See, there's nothing in L1. We don't care about L4. I should clear for, but we don't need it. I just need L1 and L2. So I go ahead and type those numbers. 5, 6, 4, 4, and 5. I have input 5 numbers on L1. Now I will go to L2. 6, 9, 3, 2, 11. Okay, so you have these 2 set of numbers listed there. Okay. Now, so you did this part. Input numbers into L1 and now go to Stat Calculations. Stat Calculation is here. So goes to the right. The very first one. But he said, no, go to the second one. Okay. Why? Because you have 2 lists. All right. Enter. I have everything in L1 and L2. So I'll put here L1 and L2. All my numbers are listed in L1 and L2, right? Okay. Now, enter. See, you remember I asked you about sum of X, sum of Y, all these numbers? Look here, you know how sum of X is 24? Sum of X2 is 118. You see all those here? You could take it from here and put there. You see in this one how Sx is 0.83? Look, I got Sx here, 0.83. Okay? You know how sample mean is 4.8? Here is 4.8. So calculator has all this for you. And here, in fact, we had also mean of Y and S of Y is these 2 numbers, right? You have those numbers here too. Okay, you have everything here. All right. Now, so that's how to find sum of X and sum of Y. If you want to use a formula, you could take all the numbers from here and input there. Now, how do I find the R value? stat, go all the way to test. We didn't say here anything about that because I'll explain that later. But since I already have the numbers, I want to just show it to you. So then scroll down all the way to, let's go scroll down to almost to the end. You see that linear regression t-test, F. Calculator already has all the numbers. You don't have to do anything here because calculator understands that you put all the numbers in L1 and L2. So you don't have to do anything. Just go all the way to calculation and see what happens. There are a bunch of stuff here. This ya plus bx, you know what it is? It is that equation. Remember I said when you have a bunch of points and there is a regression equation, that's what the regression equation is. What is a and b? I give it to you. But we are looking for r. This is your r value, 0.79, 0.795. You see that here? That's how you find your r value. When the class was not online, we actually asked the student to fill the table and then verify. Calculator was just verification, but since everything is online, then you could actually use the calculator to do all these problems. Okay, so you want me to show you one more time? We get that all the way to test. This is in case you already have all the numbers in L1 and L2. There we are, F. And you make sure you have L1 and L2. You see how it was in L1 and L2 and then calculation. Okay, all right. And now, so like they're asking you which of this graph is okay. You know how you should do it? You should put all the top ones in L1 and this is in L2 and then graph it. And then find the, and then it asks you, find the R value. You could, so it's very important for you to input all the numbers in L1 and L2. You know, for the problem we just did, I want to show you something here. For these problems, what if we ask you to plot all this? Because you already have L1 and L2, right? Okay. And you want to actually plot all these points. So what you do first is this. You see that here is stat plot, which is blue one. So you go to the second and press that. You want to make sure that in the beginning, all of these are off. All of them. You're gonna have the first one on. I already turned it on, but you know, to do it, let's say the enter. Before was like this. Let me show you here. When you do it for the first time, they all are off. Okay? You want to pick the first one. So you enter. You want to turn it on. So you make it on. And then you want to make sure you do the first one. You want this one. This is for plotting points. And all my numbers in L1 and L2. If you don't see L1 and L2 here, change it. Like when I started, it wasn't L1, it was like L3. Okay? But all my numbers in are L1 and L2, so I have to change this. So you go to second, L1. So make sure that you have listed L1 and L2. Okay, everything is fine. So this is L1 and L2 is the first graph, and this is on. When you finish, then go ahead and graph it. Sometimes when you graph it, if you don't see all the numbers correctly, so in this case, I already did it, but if you don't see all the numbers plotted, then go to zoom. Anytime your graph is not very clear, go to zoom, and then go to zoom stat and press. See, that shows you how, all the numbers plotted already, okay? So this is what we need to do for this example. So what you need to do is you need to input all these numbers in L1, all these numbers in L2. Go ahead and follow the process I just showed you and graph it, and then see which one of these is the correct one. You could, and I'll show you how to find the R value. You find the R value here. Then sometimes when you find the R value, then we ask you questions like, is this a good R or not? Regardless of the one, close to one or not. Then we already calculated R1 and R2. Table A5 here explained. Table A5, which is at the end of the textbook. Let me very quickly to see if I have a copy here. I put a copy of this formula page online. This is a formula page that we use for all the sections in this textbook, okay? And like all this formula that we discussed for the R, see, all the formula that we use for chapter 2 is here. This is chapter 3, where is it? Oh, I guess they don't have chapter 2, they start with chapter 3. But all the tables are here, and this is table A5. So statistician, what they did, they actually calculate the R a minimum. They said that when you calculate the R, this is a minimum. Your R must always be greater than what they calculate in order to claim that you have a good correlation or not. This is number of items that you use here. So in this case, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 numbers. And we normally use 5% for the alpha. So you go on table, and here, 0.05 for alpha and 11, you should have at least 0.602. See, for 11. So your R value in the problem must be greater than that. Must be greater than these numbers. What is R value? 0.815. So that means you have a good correlation. See, R of calculator, which is what? 0.815, must be greater than this R from the table. In that case, we say there is a good correlation. Okay, so there is an R value that you do through the formula or through the calculator. And for us to see if this is a strong correlation or not, this number must always be greater than the number that you find through the table. They also have the p-value. I'll show you in our problems that we basically go through the details of this section on the later chapters, almost before end of this textbook. We touch it based on this section again in very details. But here, when you go to the calculation, there's also a p-value, and that should be less than this alpha. That is another indication. So there are several ways to tell whether you have a good correlation or not. One also is the p-value. And here is, you remember how I told you to go to the test, regulation test? is all explained here. Okay, so these problems, you use the R value, you compare with the table. R of calculator must be greater than all of the tables. Alpha is always 0.05, N is 6. Why? Because there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 numbers. 6 from table A5, you must have minimum 0.811. What do we have? Very close, 0.841. It still is greater, so you have good correlations. Normally, if there is no correlation, we say R less than 0. When it comes to the correlation, we are using this symbol instead of R. It's the same thing. This Greek symbol that we use is R. R equals 0, no correlation. R is not equal 0 means there is a correlation. And then the p-value, you also find that from the calculator. It has to be, if it's less than the alpha, is alpha 0.05, then we accept that there is a correlation. Okay. So this is table A5. I put it here for you. This is another one. It's not the one that I'll show you. All right. So, and then here we are talking about regression equations. When I give you the X value and ask you to find the Y value, if you have a good correlation, you're allowed to use the regression equation to take this X, put it here to find your Y value. Okay? In these problems, first they ask you to find the R value. Then the second question is, what if we give you a value of 3,000? How do you find the Y value for it? That means you have to find the regression equation through the calculator and then take the X equal 3,000, put it for X to find your Y value. This is in case there is a good correlations. See, in these problems, here saying you have all this X and all this Y value, right? But then they say if X is 3,000, let's say after this 1,000, there is a 3,000. What's the Y value? For you to find a Y value, first you need to know whether there is a good correlation or not. We prove that there is a good correlation. How do we prove it? We find the R through the calculator, which is 0.978, and then that is greater than R through the table A5. So we do have a good correlation. When you have a good correlations, you go ahead and find this equation through the tables. I guess for this one, I can quickly go through it and show you how to do it because there are not many numbers. It won't take that long. So I can either put an L1 and L2, or I can put an L3 and L4 if I don't want to clear L1 and L2. But let's just go ahead and clear L1 and L2. So I go and clear all the list. So I put here L1, comma, L2, comma, L3, comma, let's clear everything, and L4, okay? So done. So I go to stat. See, I don't have anything on L1, right? So L1 is 1199, 862, 1010. I always encourage you to also do the problems yourself so you learn how you do it. 832, 1000. Then I go to L2, 86.4, 68.5, 80.4, 68, 66.7, 75.6. Okay, I have everything in L1 and L2, right? Okay, stat. I want to find the R value. Let's just go to test here and all the way to F. Okay. All right, enter. Do you have your list in L1 and L2? Yes. You don't have to do anything here. It goes all the way to calculations. All right. You see that A plus BX? What is the value of A? A is 21.32, right? Here in the formula is Y is A plus BX, right? A is 21.32. And what is the B? B is 0.055, 0.05x. So you take this A and B from here and put it in this. This is your equations. That's how to find it, okay? And then they're saying, okay, what if X is 3,000? How do I find the Y value? You just take the 3,000 and you put in this formula and you do the calculations. Now, before I use the regression equation, you got to check to make sure that R from the calculator is greater than, not this one, R from the calculator, which is 0.97, is greater than that one. Okay, so let's find the R here. Scroll down. R is 0.978. 0.978 is here, right? Now, what is the R from table A5? Go to table A5. How many numbers I have? 6. 1, 2, 3, 4, 5, 6. Alpha is 0.05, always 0.05. You have to have minimum 0.811, but you have 0.978, greater than that. So you have a good correlation. Remember, when you have a good correlation, then you could use the formula. Otherwise, you cannot use the formula if you don't have the good correlations, because all the points are not on the straight line. One other thing here, remember we were talking about the p-value? That's the p-value. Sometimes people think this is 7.09. It's not 7.9. Remember? You know what that e to power of -4 means? That means times 10 to power of -4. So this p-value in fact is this. It's 0.000 and then 709. Okay, so it's very, very small. It's almost 0. So when you see a number like this, don't think that this is 7.09, but because it's times 10 to power of -4. So that's how to find the p-value. And this p-value, you compare that with the alpha. And here I think they came up with 0.00355. I don't know where they got these numbers, but this in fact should be 0.007. It doesn't matter because it still is way less than 0.05. Okay. So 7.09. So the second method is your p-value. If the p-value is less than alpha, 0.005, then it's the equation. We talk about this alpha in the future sections. All right, so that would be end of chapter 2.